Hello learners, Mr. G here. We're going to be making another video relating to intermolecular forces, and this is going to be basically for grade 11, but it's also applicable for the grade 12. This is, or it was, a question paper done, a national question paper in 2017, and it is question 3. So let's go through the question. It may be a little bit tricky. Say, consider the list of 6 substances with the formula and the boiling point of that in the table below. Now we have a table. In the first column we have the name of the substances: water, ethanol, bromine, iodine, ammonia, and phosphine. And in the second column we have the formula for those specific compounds. And in the last column we have the boiling point of those compounds. Okay. So question 3.1: explain why ethanol, we're talking about ethanol, is soluble in water. Refer to the relative strengths of the intermolecular force in ethanol and water. So let's answer this question. Now, they are asking about ethanol and water. Let's quickly, and this one is not part of the work, it's not part of the question. We're going to write down the, just a second. Let's write down the Lewis dot diagram for water and for ethanol. For water will be hydrogen OH, and here is the lone pair of oxygen. This water will have hydrogen bond. Let's just fix the word. Hydrogen bond between the molecules. It is a polar molecule and will have hydrogen bond. Let's go to ethanol. Now, ethanol will be C with 3 H's in this way, another carbon here. Here will be oxygen, and oxygen is connected to hydrogen. Now, this molecule may be a little bit tricky for you to find out the shape. And remember, the shape is important for us to find out or to determine the type of intermolecular forces. Now, you can see this molecule is going to make a bend. So it's bent molecule. It is bent molecule. It is a polar molecule. It is polar molecule, and therefore, because it has hydrogen bond that is straight with oxygen, can form also hydrogen bond. So when they ask this question about what substance or why a specific substance is dissolved in another substance, the first important thing is to identify what is the type of intermolecular forces of those substances. And in this case, we have hydrogen bond and we have hydrogen bond. Second is, how are the strengths of those intermolecular forces relative to each other? So this is hydrogen bond, and they have relative the same strength. So they have the same relative strength. The same relative strength. First, we identify the type of the intermolecular forces. They are the same intermolecular forces, and therefore they have the same strength because they have the same intermolecular forces. And then, that is the important note here. Substances with comparable relative strength in intermolecular forces, I'm going to write with the abbreviation there, will dissolve. And you have to learn this one. This is an important note. Substances with comparable relative strength in intermolecular forces will dissolve. Okay, and that it is the answer for question 3.1. The marks will be one for saying identifying hydrogen bond in both of them. Identify that both of them have hydrogen bond. The other mark to state that they have the same relative strength, and the last mark is for stating this important note. That is 3 marks for this question. Let's go to the next one, 3.2. They say explain why the boiling point of iodine. Now we have to identify here, they're speaking about iodine is higher than that of bromine. So we have iodine and bromine, and you can see here iodine has, this is iodine, it have 184.3, and bromine we have only 58.8. Okay, you know iodine is a solid, it forms a crystal lattice, and bromine is a liquid. Okay, so the intermolecular forces are stronger in iodine. Okay, now the question is explain why the boiling point is stronger. So let's do the same. Let's first of all go here, this is 3.2, and go and write bromine is Br2, and the Lewis dot diagram will be Br bonding with Br, and there is the Lewis lone pair, and this is a non-polar. Non-polar, therefore it is London forces between the molecules. That will be London forces between the molecules for bromine. Now for iodine is I2, it's almost the same, I, there we go, it is also non-polar, and it is London forces. So both of them will have the same type of intermolecular forces. So why is the boiling point of iodine much higher than bromine? What is the difference here? Now, what will be the difference here? Will be the size, will be the molecular mass. So iodine has a greater, or have a larger molecular mass, or a bigger than bromine. Or you can say that iodine is a larger molecule, it's a bigger molecule than bromine. Let's write it here. Iodine is a bigger molecule than bromine. So that is important. Here, first of all, we identify that both of them will have London forces. Here in this part, both of them have London forces. Second, what is different? Well, iodine is a bigger molecule than bromine. It has a greater mass or molecular mass. Either one of them. Now, what is coming them? The bigger the molecular, the larger the surface area. If you mention the surface area, the stronger the intermolecular force. Here we are. The bigger the molecules are, the bigger the molecules, the bigger the molecular mass, whatever term you use, the stronger the London forces. And then, therefore iodine have higher boiling point than bromine. So what is the marks here? And let's quickly check the answer. First of all, iodine and bromine have London forces. There is one mark for identifying the London forces. Second, iodine has a bigger molecule or have a bigger molecular mass. The bigger the molecular mass, the stronger the London forces. Those are the 3 marks in this question. It's not that difficult. Okay, there's 3 marks in this question. Let's go to question 3.3. Sorry, the side is better. Question 3.3. Explain why phosphine will evaporate faster. Explain why phosphine will evaporate faster than ammonia by referring to the type of intermolecular forces. So now they're speaking about phosphine and they're talking about ammonia. And they say that phosphine here will evaporate faster than ammonia. So here we're talking about phosphine here and ammonia, which you have here a boiling point. So let's go to 3.3 quickly. 3.3. All right, so here is phosphine and ammonia. If we look at the Lewis dot diagram for phosphine, we have that is a P with 3 H's and a lone pair. This one is a polar molecule, and the type of intermolecular forces will be dipole-dipole. Dipole-dipole. What about ammonia? Ammonia will be nitrogen, 3 hydrogens, lone pair is also polar. If you look, they look very much the same. It's almost the same. They have the same shape, in fact, which is pyramidal, trigonal pyramidal. The difference here is the type of intermolecular force. Ammonia can form hydrogen bond. And there is obviously the first mark for this question. Identify the type of intermolecular forces that each molecule has. Okay, now what we have to speak about now? We have to speak about the strengths, compare the strengths of these intermolecular forces. So I'm going to write the notes and then I will go back. So we have to come and compare. Hydrogen bond is a stronger intermolecular force than dipole-dipole, and that will be the next mark. And the last note will be that the stronger forces will cause molecules to evaporate slower. So if you come here, the marks are first to identify the type of intermolecular force in each of the molecules, then to compare, and then to state that stronger forces will cause molecules to evaporate slower, or weaker forces will cause molecules to evaporate faster. We're going to the next question, which is 3.4. It's almost done, it's only 2 more. Water, ethanol, and bromine are all liquids at room temperature. Which one will have the higher vapor pressure? Now, important. Vapor pressure is not done now. It is going to be done in grade 12. So I'm going to write down the answer for this question, but do not stress too much about vapor pressure. The question 3.5, pardon, will be just explaining why, your decision there. Now this question is a little bit tricky because it is going to be done in grade 12. So we're going to answer and we're going to explain a little bit, but don't take too long to study this part here. Now, what is the first thing you need to know? The stronger the intermolecular force, the lower the vapor pressure. And then later on in another video, we will go to the definition of vapor pressure, exactly what it is. It is something that you are going to do in grade 12. Right now, it's not part of this video, and I don't want to make the video too long. It's already almost 15 minutes. So that is important. The stronger the intermolecular force, the lower the vapor pressure, the higher the boiling and melting point, but the lower the vapor pressure. So all you have to do is to go to the equation. You have to look for the one that have higher boiling point, and that one will have the lower vapor pressure. And they're talking about bromine. Let's look at the question. There is between water, ethanol, and bromine. Water, ethanol, and bromine. We have to look for the They say, let's just read. Ethanol, which one will have the higher? The higher vapor pressure will be the lower boiling point, and in that case will be bromine. That is the answer for that question there. Bromine is the answer because it has the higher boiling point. So the answer is bromine. And 3.5, you just have to explain why you selected or what bromine was selected. Or you have to say that the boiling point of bromine is lower than the other two liquids, therefore it has the weakest intermolecular forces. If the intermolecular forces are weak, the vapor pressure will be high, which is the first note there. So I'm going to write the note quickly, and then I will see. So here, the first part you have to say is the boiling point of bromine is lower, so it has weak intermolecular forces. It has weak intermolecular forces, remember what I explained. And then it's coming this part that I just wrote here to explain the stronger the intermolecular forces, the lower the vapor pressure. Or the other way around, the weaker the intermolecular forces, the higher the vapor pressure. This question is a good question. It was question 3, November 2017. Thank you for watching. If you think it helped, thumb up, and good luck.